just need to flip the arrangement.
Okay.
That's fine right there.
Notes. And this is definitely not the right way.
And full screen.
And full screen? It is full screen.
At the bottom.
Oh my gosh.
Right.
Okay. Cool. Okay. Sorry. Hi, everyone. We're going to get started. I'm Julie, and this is Jim. And today we're going to be talking about how to build a search engine with Python and Elasticsearch. So a little bit about us. We both work at Spring. I'm an engineering lead at Spring, and Jim is the director of engineering. For those of you who haven't heard of Spring before, Spring is a fashion e-commerce marketplace that integrates with thousands of different brands. The idea behind building Spring is similar to the reason that we believe that malls and outlet centers exist. So people like to shop in malls and outlets because they like to have options when they're shopping. And they like to be able to browse and purchase all of these products from a centralized location. So Spring's goal is to build the digital mall and become a marketplace for shopping and beauty products. So to do that, we need to build out a massive product catalog, which contains all of the fashion and beauty products in the world, which is what my team does. And while collecting data from lots of different suppliers is great, it also exposes us to a really big user problem, which is how are we going to go about creating a seamless search and browse experience with products from all of these different brands? So we've tackled this problem by building out a search engine with Python and Elasticsearch. And today we're going to be teaching you how to build something like this yourselves. We're going to be building out search functionality using a sample product data set to generate a page that looks like this where you can search from products right from your own search engine.
Cool. So I'll do a quick overview here. I want to start off by talking about our goals for this, what we think that you should be able to get out of it. Talk a little bit about the structure, what we're going to do, when we're going to do it, and then we'll move into the actual presentation. So there are two different things we're going to do today. We're going to do a couple of presentations. They will be brief. Their primary goal is to help you develop an intuition for Elasticsearch. We'll spend some time pointing out the things that we think are most important, which should save you a lot of time when you're trying to go through the problem sets. Second thing is the problem sets. This is how we're going to spend the vast majority of the time. This is time where you can work on your own laptop. The goals there are to build comfort with the Elasticsearch docs and PyElasticsearch. This is the first goal that I put up here. I think it's really valuable. We're not going to cover 95% of what Elasticsearch can do today because it can do a lot. Being able to go through the docs, learn on your own, and build up a search engine that works for whatever you're trying to search is going to be way more valuable than us trying to talk about everything. Secondary goal is to have a starting point. You can copy-paste all of the code that you use today and get started on something different. And the last thing is to actually make search work. I put that last because if you don't manage to do that by the end of the day, that's not necessarily a failure. You can learn a ton without having anything that works that well. But I'm confident that y'all have something working. Here's our agenda. You can read it. There are 3 problem sets. They each focus on a different part of Elasticsearch. The first is putting data into Elasticsearch. The second is getting data out of Elasticsearch. And then the third is doing a little bit more advanced analysis on the data that you're putting into Elasticsearch so that you get better query results at the end. There are breaks in here. The break at 10:10, there are snacks outside. The break technically starts at 10:15, but you're going to be working on a problem set before that. So walk out whenever you want, grab some snacks, come back. And try to be back around 10:25 when we'll kick off the introduction to searching. This is my advice for the problem sets. You don't have to follow it. You're all adults. But I think it'll be way more effective if you do this. Work in groups, help each other learn. I recommend that everybody has their own laptop. Everybody types in the code and tries to make it work. But ask each other questions. you're all sitting next to each other. You're at convenient tables that make it easy for 2 or 3 people to work together. Really hard for more than that to work together, but if you want to turn around and talk to your neighbors behind you, that's awesome too. But very much try to help each other learn. The old adages about learning more by teaching, et cetera, it really is effective. Second, take your time. It's not a race. If you try and race through this, I'm sure you can do it in an hour, but you won't learn anything. If you take your time, try and really work through things on your own, don't look at the hints too early, you'll get a lot more out of it. And the third thing, again, is read the docs. Elasticsearch has really amazing documentation. It can be difficult to parse through, but once you get used to it, it's incredibly valuable. Some of the problems have spoilers on them. So we're using GitHub Markdown documents for the problem sets. There will be little arrows that you can click to open up. I put things in there that I think you don't need to know to solve the problem, but that can be really helpful to get yourself back on the right path if you feel lost. Try to figure things out on your own. Read the spoilers if you feel like you need them. If you're getting frustrated or annoyed and there's a spoiler there, open it. If you use Internet Explorer, then the spoilers will all be open by default. All right, into the actual content. So I'm going to run through a brief introduction of Elasticsearch, how I think about it, what I think Elasticsearch is. The first slide is as many buzzwords as I could fit. A search-optimized, distributed database built on top of Lucene. I'm going to go through these words one by one. The easy one first, it's a database. You put data in, you get data back out. It has a really, really nice query UI. Everything's done over HTTP. Everything is done with JSON documents. So in general, you'll be posting a JSON document to Elasticsearch, and it'll be returning a JSON document back to you. In general, Elasticsearch is not used as a primary data store. What that means is you'll have your data somewhere else. For the purposes of this tutorial, somewhere else is a giant JSON file that we checked into the repo. In real life, it's usually going to be some SQL database or Mongo or other NoSQL solution. Elasticsearch does not have the best properties around remembering the data that you gave to it. And it's not designed for giving you back exactly what you said to it. It's designed for search. Second part, Lucene. This is a thing you probably don't need to know, but when you're reading through the documentation, every now and then this abstraction leaks. So Elasticsearch is a wrapper around Lucene. It adds a ton of functionality. It adds a really friendly user interface. But the core searching and data storage are all handled by this Java package called Lucene. You shouldn't have to know this, but you do. Elasticsearch is distributed. You usually run a cluster. You have a bunch of instances. It behaves really nicely in clusters. You can just go and spin up 5 of them, tell them where each other server lives, and it will handle everything for you. This is how Elasticsearch handles its scaling story. You can make very large clusters that work very effectively. And lastly, most importantly, it's search optimized. So it uses Lucene and the indexing strategies that Lucene provides to store your data in a way that makes it easy to search. You'll end up seeing in the documentation something called an inverted index. This is basically an index that flips, so it's easy to search by content and find the identifier, instead of being easy to search by identifier and find the content. And then it provides this very rich query language for letting you build up very complicated searches and executing those searches quickly. And then the last thing is built-in support for text analysis. We'll talk about this a bunch towards the end of the day. But it does a lot of work for you in taking your raw documents that are just English text and turning that into something that can effectively be searched. Database structure. I'm going to do an analogy here between Elasticsearch and a SQL database. It's basically the same for a document-oriented database or something like Mongo. But the Elasticsearch word is on the left, the SQL word is on the right. You have an index. You can think of this as a table. It contains a bunch of documents, which you can think of as rows. Each document has a schema. This is super confusing. Elasticsearch version 6.2, which is what we're working on now, lets you put different types of documents in the same index. This is planned to be deprecated in future versions. So in the future, this document type arrow will just point to the table, which is where you might expect it to go. During this tutorial, we're only going to use one kind of document type against one kind of index, so this shouldn't matter too much. But when you're going through things, you might get an error like you have two doc types in this index, or you might get errors about not specifying the correct document type. So it's important to have this in your mind. This is the actual structure we're going to use for the tutorial. Our index is called the products index. Those are some brilliantly named products. And the document type is going to be product. These are stored in a couple of constants in the code base, so you'll mostly reference them as constants.index. Julie, getting data in.
So like Jim mentioned in the agenda, for the first part of this tutorial, we're going to talk about how to index data or get it into Elasticsearch. So I'm going to walk through a visualization of what that looks like, some of the dev tools that you can use to help you, and then we'll move into working on a problem set. So if we think about Elasticsearch being as a service and a database, then one of the first things that we need to do is actually get data into Elasticsearch before we can make queries about it. So what does that process for getting data into Elasticsearch look like? Well, first we need to have some data that we actually want to put in Elasticsearch. And that data, as Jim mentioned, has to be structured as JSON before we can make a request and send it to Elasticsearch. So for those of you who haven't worked with JSON before, the key thing to know is that the primary attribute of JSON is data comes as a key value pair. And we can also communicate with Elasticsearch over a REST API. So to put data into Elasticsearch, we would send a JSON document to an indexing API. In this case, the JSON data that we are sending is a product whose name is shirt with an image URL, which is shirtphoto.com. So going back to the database structure that Jim just described, we can see that sending this request would create a document like this in Elasticsearch. So we sent it to the products index, mapped it to a schema of doc type product, and now we can see this document actually in Elasticsearch. So because Elasticsearch communicates over HTTP, we can actually look at our Elasticsearch index just from the browser. So for those of you who had a chance to complete the pre-work, if you go to your URL bar and type in localhost 9200, you should be able to see a page like this, which simply just tells you that you have an Elasticsearch cluster running locally. If it doesn't work right now, don't worry about it. We'll come over and help you during the problem set portion. We can also look at a lot of stuff, not just from our browser and using curl commands, but when you install Elasticsearch, it actually has some really nicely built dev tools that comes with it. So we're going to use that now to look at some examples. If you completed the pre-work and installed Kibana, you can access these dev tools by going to localhost 5601. I put up a bit.ly URL here, so for those of you who haven't installed, it's actually best to just type in this bit.ly URL to follow along. What this does is it'll redirect you to a specific URL on localhost 5601, which makes a request to a JSON document that I already typed out. So for those of you who had a chance to look at the Elasticsearch cluster, this is what you'd see. And then if you go to the bit.ly link I had just typed out, this is what it looks like. I'll copy and paste that to the URL bar, so for anyone who's looking for it. Cool, so this is the Kibana dev tools. What it allows us to do is essentially just make requests to the Elasticsearch API. You can do the same thing by using curl or other libraries to make curl commands, like I've used Postman before, but what's really nice about this is that it's designed specifically to make Elasticsearch queries, so it'll autocomplete, highlight syntax errors, and do other nice things for you. So we're going to walk through 3 different things right now using the dev tools. The first is we're going to create a document in our Elasticsearch cluster. And we're going to be doing that by using the post command. So let's add our first JSON doc. So if we take a look at this example that I typed out here, what this command says is post / products index test / products. So we are going to post this blob below and send it to this index and this type. So if you click this green play button, we can see that it's created a document for us. It has this ID because when you create a document with post, it auto-generates an ID for you. This is the first version that we're seeing this document in, and we can see that it was successful. So indexing the document also automatically actually created the index for us called products index test. For those of you who've worked as SQL before, you might be used to having to run a migration to specify the structure of your table. But the nice thing about Elasticsearch is that if you don't specify what the index is beforehand, it'll actually just dynamically create it for you. So now we have this product in the index, and let's find it using a get command. So what this command does is it goes ahead and gets every single item out of products index test. So if we run this, I think we ran it a couple times before the tutorial, so that's why there's 3, but you should actually only see 1 hit. I'm gonna delete this real quick and rerun it so that I'm on the same page as all of you. So now you see that there's only 1 item in the index, and it has the data that we specified with the name, orange shirt, and the description. This is an orange shirt. Another way in which we can create documents is by using a put request. So post works by creating it creates the document's ID for us, but put actually requires an ID for the document as part of the URL. So we can see here that by running a post command, it gave us this ID, which was like KXO, randomly generated ID. If we try to run the exact same command with put without specifying an ID, we're gonna see that we'll get this error, which tells us this is an incorrect HTTP method. You had to specify an ID. So this error is expected. We're gonna run this instead. And now we can see that this has been successfully put into our index. We now have a document with ID 1. If we run this get command again to see what is in our products index, we'll see that now we have 2 things in the products index. One is orange shirt with the description. This is an orange shirt, and this randomly generated ID. And another is blue shirt. This is a blue shirt, and it has an ID of 1. Lastly, when we have a lot of documents, it doesn't necessarily make sense to run this command every single time. So for example, at Spring, we have over 50 million rows in our products table. If we wanted to put all of that into Elasticsearch, it wouldn't necessarily make sense to run that every single time. So instead, what we do is we use the bulk API, and using this, especially on large data sets, allows you to see a lot of performance benefits. So now we're gonna add 2 more documents here with the bulk API, a green shirt and a purple shirt. And when we run this and run this command to get all the documents again, we now see that we have 4 items, an orange shirt, a green shirt, a blue shirt, and a purple shirt. So that's basically an intro to the dev tools. This is super useful when you're working with Elasticsearch because sometimes if you need to debug things in Python, it's easier just to get to the raw query and run that command. So know that this is available to you today as we're working through the problem sets. I'm gonna go ahead and delete this index now because we don't need it for the rest of the tutorial.
Immediately close this presentation again, I think.
Oh, right.
All right, I'm gonna talk for like 1 or 2 more minutes, and then we're gonna switch over to you actually doing things. Let me just peek at my next slide. Indexing. Yeah, okay, that's a real slide. All right, before I go into those, I'm gonna just take you through a brief overview of what you have if you've checked out the repo, and then some of the resources that you'll want to look at. So let's open my terminal. So I'm in the repository here. Is font size okay? All right, I saw one thumbs up in the back. Must be perfect for everyone. So in this repository, there are a couple of commands that you're going to run a lot. One of them is Python search app / index products.py. This is going to break because I forgot to activate my virtual environment. You're going to see this at some point. Bin activate, perfect. So index products is the script that we wrote that will index products into Elasticsearch. You can see it works great. It indexes a single great product. There are about 20,000 products in the data set that we gave you. The first problem set is going to take you through making it actually index those products. The second thing that you'll want to do is actually run the test server. So search app / run.py. I already have it running in a different tab, which is why this broke. But now that's run, you can go over, and when you start, you should have a version of the app that looks like this. So this is a nice little test harness for looking at a variety of different searches and seeing what kind of results you get from them. As you can see, we currently get a picture of some kittens with a description, a great product, for every search, which I think is perfect. The tools you have here are searching for arbitrary strings, which just gives you kittens. And you can also click on a product to get a description of it. You can see here, you get a description of a different product right now because I pretended that those kittens were a pair of 835 mid-rise capris. But once you get through the indexing, this will actually work and show you more information about the product. That's a useful way to go in and see what data does this product contain, so you can try and understand why the search term you gave returned that product. I want to pull up the Elasticsearch documentation really quickly. So I'm just going to start with this page. And the internet is questionable. Whoop. Hopefully your internet will be better than mine. Hopefully you have unlimited data.
We can all hotspot from Jim's phone.
No. All right. Hey, the demo gods are kind. Okay, so actually on these search results, you can see the first gotcha, which is you get 6.2, 6.1, 2.1, 1.4. You want 6.2. When you're on a page, there is a drop down here, which lets you pick the version. So basically, anytime you end up on an Elasticsearch documentation page, the first thing you should do is scroll down and look at this and make sure it's set to 6.2. I have spent more hours than I care to admit reading the wrong version of the documentation. The other neat trick is that there's this magic link, view in console. So if you're ever looking at something here and that seems like this is probably what I want, you can click view in console. It links you off to your local Kibana console, and then you can play with the query and see the results that you get. For a very brief tour of the code, there are two functions where you're going to spend basically all of your time. So you're going to start off in search app / indexproducts.py, and here you're interested in the main function. You can see that right now it deletes the index and ignores 404 responses. If the index doesn't exist, we don't care that it didn't get deleted. Judging by people leaning forward, I'm just going to make this a lot bigger.
It's the contrast, actually.
Let's see if this is better. Slightly better. Cool. And it's all gone. Okay. So it deletes the index, it creates a new index, and then it indexes the first product, and as you can see, it just inserts a great product. So you'll spend some time in here for the first session trying to figure out how to make this index the actual data. And then you'll spend a bunch of time in search.py, where we have this beautiful query that matches everything, making that into something that actually depends on the term that is passed in. Let's pop back to the slides real quick. I just showed you this, but it's worth calling out. There's a folder called Search Up in the bottom of the repository. The files that you care about are all inside of that. We're going to be using Elasticsearch Pi, which is the official Elasticsearch library. It has a URL. Their documentation is also great. And here's this slide again. Problem sets. My advice is to work in groups. Take your time and read the docs. Here's the link for the first problem set. If you get to the end of this problem set before we interrupt you or before the break, feel free to just keep going, open up problem set number 2, and get ahead of things. Or take some time to go back, read through it, make sure that you really understand what happened in that problem set, and see if there are ways to make it better. Yeah.
And also, if you need help setting up the prereqs, feel free to raise your hand now and we'll come over to you. But that's all for now until the break at 10:10.
Yep. In general, if you need help, just gesticulate wildly. We'll come find you. If we both look busy, then we're probably both busy. But we'll come as quickly as we can. All right, go do. to turn caffeine on while presenting. Cool. Thank you. So if you care about snacks, you should go now. If you don't care, you're welcome to hang out.
to be able to get tags? Is it just get checkout?
So they're gonna have to fetch first. And
Okay.
then we probably want to tell them to commit their current work so they don't lose it. And then check out.
Okay, so I just want to, I'm going to make a slide of all the commands, which is, okay, so git commit, git add, dot,
Just do git commit dash am.
okay.
Sure.
Okay, what else? I also put it on
Git fetch. And then git checkout, that's big.
check out, what? Hey everyone, we're gonna get started again in about a minute or two as soon as we turn on the monitor. Okay, we're gonna get started with searching. So now that we know how to index our data, we're actually gonna be talking about how to make structured queries to ask questions about this data. A lot of you have kind of asked, I've been looking at my Flask app, all the results are coming back the same. That's because we haven't actually built out any search functionality yet. We've just put data into Elasticsearch. So the next thing we're gonna do is we're gonna build out functionality so that you can actually make a request from the UI that you've been looking at and get data out of Elasticsearch. As some of you might have noticed, the browser is making requests to Elasticsearch, and in the background we have a Flask app that's running. The Flask app sends a request to Elasticsearch via the Elasticsearch API. And we're gonna take a look at what that looks like using the Kibana dev tools. So for all of you who have Kibana up and running, if you can type in that URL, it will bring you to this page. So this is the Kibana dev tools console again, and we're gonna use it to be interacting with Elasticsearch. In this part, we're going to be actually querying data with the get command. So we've seen how to use post and put to create documents. Let's talk about getting out the documents that we want. If you finished part 1, you should now have about 20,000 products in the index, and we can search for them. So first, we're going to run this command, which actually gets us all the different products. So we actually didn't run it on our computer, but if you index all the products properly, that should now say 20,000 different products. We only have one, but you should have more.
Let's have products.
Okay. We're going to index really quickly, so we also have products.
Demos are great. But you can see we just checked out the bulk indexing branch.
Yeah. Yes. Okay, awesome. Because for those in the back who can't see, it's bit.ly PyCon-ES-DevTools2. Cool. Are we good? Awesome. That's cool. So now we just bulk index a bunch of products. So we still don't have products. Do we do it to the right index?
Demos never fail.
Live demos. But for everyone else who's run that command, I hope you'll be able to see some products in the DevTools console. Oh, we're on the wrong commit.
Are we?
I don't know, were we?
Connect to the hotspot.
We're on the hotspot. We got the Google shortener.
All right. I have no idea.
Okay. Well, instead of live debugging in front of everyone, you can just try that command from your DevTools. That query is the same exact query as this one, which is we are matching on everything and getting everything back. What's probably more interesting, which is what we're going to be doing during this part, is we want to actually run specific queries. So an example of one that we are going to run in the problem set is one where we can just get necklaces. So what this is saying is look here, look in the products index and search using the query, a match query, and get me back everything that has necklaces in the name. So this isn't going to work, but had we had a lot of different results, actually we can see it on this one, we can see that each of them would actually get a specific score. And so that score, which will be ideally different for the products that are returning for you, tells you basically like should the orders in which the product should be showing up in. And there's a lot of documentation about relevance scoring on the Elasticsearch docs. So next. So in order to make it easier for us to actually build out a search engine in Python with Elasticsearch, we're going to be talking about using the Elasticsearch DSL. In the first part, we talked about how we would use Elasticsearch Py to communicate with Elasticsearch. The Elasticsearch DSL is simply another Python library that puts a wrapper around that and helps us write and run Elasticsearch queries. So for example, let's take a look at this raw query that we just looked at in our dev tools. So what this query is saying is we want to run a match query and give me back products with the name necklace. We send this to Elasticsearch by making a GET request to localhost 9200 products index product. To do this with the Elasticsearch DSL, we would start by importing the Python Elasticsearch client, which is just a wrapper around Elasticsearch REST API. We actually use this client in part 1 in order to index the products, and we're going to use the same client again in part 2 for search. This is what allows us to really easily communicate with Elasticsearch. The second part, which is what we're actually using from the Elasticsearch DSL, is the search object. So what we use this for is to initiate it with the client to construct a query to the products index and doc type. And then we actually use the search object to construct a match query. So you can see sort of the similarities that we can find here between the raw match query and the actual one that we're writing in Python. So we're going to dive into another problem set now. For those of you who were able to finish part 1 and get all of the products into your index, you can actually just continue by using that bit.ly link to take you to lesson 2. If you're in the middle of part 1, you have two options. You can either continue trying out indexing and getting into work, or if you want to move along and play around with search, we can do that just by following these commands. So commit the changes that you have from part 1, fetch the latest copy of the repository, and then check out that tag, which is session 2. And all of these instructions are all on the GitHub repositories if you go to the main page. So you can probably just copy and paste it from there as well. And like we did in the first part, we'll walk around and answer any questions.
And just a brief warning, I just ran these commands and my index didn't work, so I'm going to debug that real quick, and I'll let you know if it's broken. But if you have trouble with this, just give me a minute.
Yeah, or raise your hand and I'll come over as well.
instructions work. We were just using the wrong index in our script.
everyone. We have about 37 minutes left in the tutorial, so we're going to get started with talking about analyzers and then let you continue working from there on either whichever problem set you want to keep working on.
Awesome. Analysis. So this is going to be relatively quick. The goal here is to talk through what Elasticsearch does when it analyzes documents and give you some intuition for what that is capable of. So analyzers improve search accuracy by adding additional structure to text. So you're going to give Elasticsearch, say, the description of a product, which is this huge document full of words, most of which aren't very useful. It also has all sorts of arbitrary structure in it, like bullet points and colons and commas and English grammar that do not help people when they're searching, even though they do help you actually read the text. The flow of an analyzer looks something like this. So you get some raw data in, like walking the dog. You tokenize that data, which means you split it up into the individual chunks that you believe will be most useful. The standard tokenizer splits on spaces, actually splits on anything that is specified in the Unicode standard as not being part of a word. You can see in this case it drops the colon after the and just breaks up by words. You then go through and do a series of token filters, 0 or more of them, to try and cut out information that's not useful. So in this case, we dropped a stop word. The word "the" is so commonly occurring in English that it's just not useful in searches, so it gets removed entirely. And then we took the word "walking" and shortened it to the word "walk." That's a process called stemming. Basically, you want to cut off the end of the word in cases where there are lots of different endings that could be applied. So walking, walks, walker, all of those get cut down to walk. And that means that if you search for any of those terms, you'll find matches against all of those terms. Here are a couple of the built-in tokenizers that Elasticsearch provides to you. So there's the standard one, which I pointed out. There's the white space one, which is incredibly naive. It just splits on white space. In this case, the difference here is that it includes the colon, which will really muck up your search results. And then edge engrams is a really useful one for doing suggestions. So this will, for every word, return every prefix. So if somebody types in WAL, it'll directly match against one of these tokens. On the filtration side, we're just going to look here at the analyzer, or the series of token filters used by the English analyzer. That's a built-in analyzer that Elasticsearch provides you. So the first step here is convert everything to lowercase. Don't need to worry about that. The second I touched on briefly, eliminate stop words. And the third is perform stemming. So you end up with this series of tokens, and that's what's actually going to get stored, and that's what's actually searched against. You configure analyzers at the index level. So in the mapping of your index, you'll say, this field should be analyzed using, say, the standard English analyzer, or using my custom analyzer that understands that this data is a little bit different from things that people generally put in Elasticsearch. And so I want to take a couple of extra steps to try and normalize it and make it as easy to search as possible. Those custom analyzers are created in the settings of your index. If you look at indexproducts.py, you'll see that I broke out mapping and settings as a couple of properties. Right now we pass no data to either of those properties, but that's where analyzers would be configured. Spacebar does not work. An important note, analyzers are applied to both the fields of your document when you index them and to every query made against that document. So what that means is if you take a query string like walking the dog and you use it to query against 3 different fields in your product, it might go through 3 different analysis pipelines, come out as a totally different set of tokens, and those tokens will be used against the appropriate fields. So this is really powerful for taking search terms that look like your input data and normalizing both of them to eliminate all of the unnecessary stop words, stemming, etc. All right, back to the problem sets. I recommend that you just kick off where you were before I started talking and keep going through. But if you want to jump forward to the analyzers, go for it. We have about half an hour left. We'll stop you maybe 5 minutes before noon to talk through our last couple of slides, and then let you be free on the wonderful city of Cleveland.
And that's the link for the third lesson if you wanted to get started with it. At the end of the tutorial, there's also a survey that PyCon has asked us for you to take, and we would love for you to take. So that's the link to the survey as well if you wanted to get started early on that. everyone. It's now 12 o'clock, so I think officially the tutorial is over. Thank you all for coming and building a search engine with us, and please take this survey. The link is bit.ly/PyCon-ES-survey. And we'll make all of the slides and materials available on the same GitHub repository that you've been working on, so you can access all of the resources even after the tutorial's over. Cool. Thank you.